Hello everyone. Today let's solve the problem Xenia and bit operations. Right. So you can read the entire question. So I'll just summarize it for you. So they have given the examples as well with the input and the desired output for this particular input. Right. So also you can they have clearly mentioned the problem statement. You can read it entirely. So I'll just summarize the question for you so that it will be easy to understand. Right. So I'll just come here. So what the question states here, the problem involves a sequence of 2 to the power of n integers. So it involves a sequence of integers. It involves a sequence of 2 to the power of n integers. Right. So this is one thing. So where we alternate between performing bitwise OR and bitwise XOR operations on adjacent elements. So we are performing this one XOR and OR and XOR operations, right, on the adjacency. One second. Yeah, on the adjacent elements to reduce the sequence of single elements, single element V. So to reduce the sequence to the single element V, we are performing OR and XOR operations on the adjacent elements, and we have been given 2 to the power of n integers. So this is one thing you have to keep in head. So after each query which updates a specific element in the sequence, we calculate and output the new value of V. So this is very important. After every query or after each query, we will be updating the specific element in the sequence, and we recalculate the output, the new value of V. Nothing but we are recalculating the new value of V after each query, right? So that is what they have given. So this challenge focuses on updating the sequence efficiently after each query. So we are focusing on updating the sequence efficiently after the each query. So mainly this is the question. So let's discuss the approach and write the code, right? So I'll just delete this one. I'll just give me a second. So let's discuss the approach. So first step is we always know that we'll be going with input handling or input reading. So this is completely this one. It is related to the input, taking input and reading the input, right? So first we'll be going with the input reading or the input handling. So the approach that will be going, the language that we'll be using here is JavaScript or the Node, right? So first step is input reading. The second step is input parsing. So what we'll do here in this step is we will read the number of integers n and number of queries m. So number of integers is nothing but n and number of queries is nothing but m. We will read these two, number of integers as well as number of queries. The sequence contains 2 to the power of n elements, as I have said this one in the question. So we are reading number of elements and number of queries, number of integers and number of queries. This one is number of integers. I'll just give this I. This is number of queries. I'll just give this Q. So we have a sequence of integers 2 to the power of n. So that's what we'll be doing in the second step. After reading the number of integers and number of queries, let's come to the third step. So we are performing bitwise operations, right? So for each query, we will update one element of the sequence. Again, I'm telling, for each query. So for every individual query, we will be updating one element of the sequence. Only one element of the sequence, and the problem requires alternating between bitwise OR and bitwise AND. So the problem requires alternating between bitwise OR and bitwise XOR. Right, these two operations. So operations on adjacent pairs until only one element remains. While explaining question itself, I have explained that we have to get only one element, right? And we have to perform bitwise OR and bitwise XOR operations on the adjacent pairs. That's what we will be doing here. Nothing but we are performing the bitwise operations in the third step. After performing the bitwise operations in the third step, in the fourth step, what we'll be doing? We'll be going with this one, segment tree approach. For this particular problem, all you have to know is, mainly know is, we have to perform bitwise operations, bitwise OR and this one, XOR operation. Also, the main approach that we will be going with to solve this problem is segment tree. So these two things you have to know clearly. So why we are making use of the segment tree here? To efficiently manage update and recomputation. So that is the reasons we'll be making use of segment tree. We use segment tree like structure, right? The first level of the tree will store the initial sequence. Always suppose this is first level. First level of the tree always stores the initial sequence. Nothing but this one. This one is the first level, right? So this will store the initial sequence. The first level of the tree always stores the initial sequence, and higher level stores the results of the bitwise OR and XOR operations at each step. At each step, higher level will store the bitwise OR and bitwise XOR operations, right? XOR and OR. So higher level will store the results of bitwise OR and XOR operations at each step. So at every step, it will store XOR and same thing, XOR and OR operations. So this is what we'll be doing in this one, fourth step. So this is nothing but we'll be going with the segment tree approach, right? I'll just give segment tree approach here. This will be the fourth step. So here the fifth step will be, after this one we have to process the queries, right, at each step. So for each query we will update the corresponding elements at every level of the segment tree. What we will do, for each query we will be updating the corresponding element, then we will propagate the change towards upwards, not towards. So we will propagate the change upwards through the segment tree to adjust the result based on the new value. So we will be updating, and we will be updating. Suppose every element has the parent element, right? So we'll be calculating this one. First, we'll perform bitwise OR and XOR element, this one, XOR operations for the adjacency element, and I'll be storing that one in the segment tree, and the update at each level will be storing the update at the parent level or the higher level, right? So in simple terms, for each query we will be updating the corresponding element, then propagate the change upwards through the segment tree to adjust the result based on the new value. So we'll be getting the new value, and based on that one we'll be adjusting the result, right? So this is here nothing but processing queries. So I'll just give PQ. This is not priority queue. This is processing queries basically. So finally, we at the sixth step, we have to display the result, or we have to output the result, right? We'll be getting the output in the fifth step. So we have to output the result. So we are making use of the Node.js or the JavaScript, right? So directly we can make use of this one, console log, to print the result. So for printing, I'll be making use of console log. So this is the approach that we'll be going with for this particular problem. So bitwise X and OR operations and segment tree. Also processing the queries. These things you need to keep in mind, right? So I'll just delete this one. Let's start writing the code so that you'll get to know the things in a easy way. First thing is, we are required to read the inputs from the file in. We are required to read the inputs from the file, right? That's why I'll just import the fs module. So I'll just give, it has to be require fs. So this is one thing. Next, I'll just consider the input. So we have to read the input. For that, I'll just make use of read file sync. This one will start with 0 and set the encoding to UTF-8. This is one thing. Also, we have to read the, we have to eliminate the unnecessary spaces I found in the input, right, while reading. So for that purpose, I'll just be making use of trim. And we have to read the line, we have to read the input line by line. So for that purpose, I'll just make use of split here. So I'll just make use of the regular expressions. This one, yeah. So I hope this is clear. Next, to track the current line that is being read from the input, we will initialize the count to 0. Initially, the count we will set this one to 0. Also, let me take the custom function named renum. I'll just set this one to I'll just take this and let's increment the count. So why we are incrementing the count? We have to read the input line by line. First, we'll initialize that one to 0, and we have to read the count line by line, right? First line we will read, that will be 0. Next, it has to come to 1, 2, and until the input is present, and we have to read the line each by line. That is the reason we'll be incrementing the count, right? So next, so suppose there are distinct numbers in the same line, or more than one number in the same line. We need spaces, right? We need space at that particular time. So for that reason, I'll be making use of the split and I'll be leaving the space. So I'll just make use of map everything. So let me take some random character and I'll just give plus here for reading. So I hope this is clear. Next, we'll make use of the utility class to create the custom dictionary with the default using begin. So we'll be making use of the custom utility class to create the custom dictionary with default values. So we are going with the default values. So we'll be making use of the begin. So here we'll be dealing with the large integers or the large inputs. So I'll make use of the begin here, right? So let me make use of the class my dict. Sorry, just give me a second. So what happened here? Just give me a second here. So yeah, here let me make use of the constructor. Let me consider function, or I'll just take func. This one, let's set this one to 0. So inside the constructor, what we'll be doing? We'll be creating the random begin value. Also, we will take the function to provide a default value when key doesn't exist. So dictionary consists of the key and value. So here, when the key doesn't exist, we will provide the function to provide we'll be making use of the function to provide the default value. First step is we'll create the random begin value. We will create the function to provide a default value when key doesn't exist. Also, the dictionary, we will be going with the dictionary to store the key value pairs. So this one, for the random begin value, I'll just take random. Yeah, this one I'll just set this one to begin. So this I has to be capital, right? So this is fine. Begin of for the math.floor operations, I'm just making use of math.floor here. Instead of the math.floor, I'll be making use of double tilde. So this is somewhat faster compared to math.floor, right? So as I'm making use of the random value, I'll just go with math.random. So here into, it will be between 0 to 1, right? So I'll just provide the numbers. It will be full. So I'll just go with this one, 32. So this is fine. Next, let's declare the function to provide a default value when the key doesn't exist. So I'll just give this one, this dot default equals func. So also, let's I'll just provide the dictionary to store the key value pair. Nothing but I'll just take this one, this dot dict equals this one, right? So this is fine. So here I have to give this, right? Sorry, this one has to be this. Next, what we'll do, we have to get the key. So we are performing get operation here. Get of key, parameter key. So the first thing here that we'll do is, we'll be performing XOR with random value to create the unique keys. So we need the unique keys. How can we get the unique keys? We'll just perform the XOR with the XOR operation with the random value. I hope this will work. I'll just give const instead of const. I'll just take let. So let my key. Here I'll just give. I'll just give small k itself here. How can we perform the XOR operation? I'll just give here. We have already took this dot random, right? So this one will make use of begin of key. So this is one thing. So next step is, we'll assign the default value if the key is not present. So if the key is not present, here you can see in the constructor, here this dot default we have made use of, right? If key is not at all present, then we will assign the default value, right? And we will return the value that is, finally we will return the value that is associated with the key. So I'll say in simple term, I'll just go with the if condition. Here if this dot take of my key, then we have to perform the default value, right? I can just give, this has to be take my key, this one. I'll just set this one to this dot default. So why we are doing this? We are assigning the default value if the key is not present. As I have said, finally we have to return the value that is associated with the key. This is simple. I'll just give return this dot dig of my key. This is fine. So then after this step, we have to update the key and value. I'll just be making use of set for this. So here it consists of key as well as the value as parameters. So first thing here is, we'll be performing the XOR with the random value to create the unique keys. In previous step also, we have done the same thing, right? You'll be knowing by this. You'll be knowing this by this time. Also, we will be setting the key value pair in the dictionary finally. So first, we'll be performing XOR operations with the random value to create the unique keys, first thing, and we will be setting the key value pair in the dictionary. So the first, this one is same. Let my key, I'll just copy this one, this random. This one, let me copy this and paste it over here. Also, we have to set the key value pair in the dictionary. So this one will be start of my key. Will set this one to value. So value we already have, right? So this is fine. So after this, what we will do? Just give me a second here. I just got confused actually. Yeah. Let's write the main function over here. So I'll just give function. I'll just take the function name solve or main, anything. I'll just take solve here. So in the first step, we will be reading the first input line. So we have to read the number of levels as well as the number of queries, right? Number of levels is nothing but n and number of queries is nothing but q. So we have to read both, right? So I'll just consider this one, what do you call destructuring operator. I'll just be giving here, we have made use of the custom readnum function, right, to read the individual lines. So we have to read number of levels nothing but n and the number of queries nothing but q. So I'll just give here nq readnum. So next we will be reading the initial sequence of 2 to the power of n elements. So for this one, I'll just consider the variable name a. Let me give the same thing, readnum again. So this is one thing. Next, let's initialize a tree structure that is similar to the segment tree to store the results. Nothing but the tree has n+1 levels, right? So at each level, we will be storing the intermediate results of the operations. So I'll give let tree equals array dot from here. Let's consider array of length n+1. Also here, have to assign this one to new array of size 1. Here we have to perform this operation, right? Also plus 1, and finally we will fill initially this one with the value 0. So this is fine. Next, let's populate the base level of the tree with the initial array A. So we are done with the initialization. Next, as usual, we'll be going with the iteration, right? Nothing but we are populating the base level of the tree with the initial array A. So I can just give here for let I equals 0 less than length of the A and increment the I. Nothing but here tree of 0 I plus 1. Let's set this one to iterated value of the A. So I hope this is clear, right? So I hope this is fine. Next, let's pre-compute the tree using OR and XOR operations, alternating each level. So yeah, we'll pre-compute the values of in the tree using OR and XOR operations, alternating at each level. Again, nothing but we'll be going with the iteration. So I'll just come here. Let I equals 1, I less than or equal to n. Let's increment the I. If I module 2, if it is equal to 1, nothing but if it is odd, then what we will do? Odd levels, right? I module 2 equals 1 is nothing but if the value is odd, then we will perform the bitwise OR on adjacent elements. If the if the level is odd, then we'll be performing the bitwise OR on adjacent elements. Nothing but again, I'll go with the iteration. This will be j equals 1. J less than or equals to 1. This one n minus 1. Also, we will be incrementing the j. This is fine. Then tree of ij. This will be tree of I minus 1. 2 into j minus 1. This has to be, just make use of, we are performing the bitwise OR operation, right? On the adjacent elements, right? This one was tree of I minus 1, 2 into j minus 1. Also, I minus 1, 2 into j. Yeah, this will be, yeah, correct. This will be adjacent element means this has to be I minus 1 and 2 into j. Yeah, this is fine. So else what we will be doing, if it is not 1, means if it is not odd, then for the even levels, we'll be performing bitwise XOR on the adjacent elements. So if it is, so here in this step you can clearly see if the level is odd, then we'll be performing bitwise or XOR operations. Bitwise OR on adjacent elements. Else if it is even, then we will be performing bitwise XOR on adjacent elements. Again, so for this, again, I'll just be going with for loop. Here it will be j equals 1, j less than or equal to, this has to be n minus 1, correct? And implement the j. So we have to perform the XOR operations on the adjacent elements, right? Same thing. I'll just copy the same thing. Just give me a second. 1 second. So same thing here. This one. So instead of this one, or we have to perform bitwise XOR, right? So I'll change, just change this symbol. So this will be same. We are performing the bitwise OR operations, and here we'll be performing the bitwise XOR operation on the adjacent elements. Everything will be same, but here it will be only we have to change this one XOR to, OR to XOR, right? That's what I have changed here. So I hope this works correctly. So next, after this step, as we had discussed in the approach, we have to process the each query to update the tree and recompute the result. So we had discussed earlier that why we have to process each query and update the tree. So we have to process the each query to update nothing but we'll get the new value. Nothing but we'll be updating the tree with the new value and we will recompute the result. For that, again, I'll just be going with the for loop. Here, for let I equals 0, same to I less than. For the query, we have considered Q, right? This will be I plus plus. So we have to read the query P and B. That is nothing but P is nothing but index to update. Nothing but we have to update, right? We have to update the particular index after each query, and we have to get the new value as well. So P will be index to update and new value will be B. So I'll just be making use of the destructuring operator here. Just come here and give PB. This one too, we have to read this one. So I'll be making use of the read num. So here tree of 0 and P, this will be equal to B. So this is fine. Next step, we will be propagating the change upwards through the tree. So nothing but we will be we'll be going with the new values upwards, right? So we had discussed this one in the approach. Nothing but we'll be propagating or going with the change upwards through the tree. So I'll just give here for the upwards. I can give in this way, right? P equals P plus 1. So this one, nothing but we are adjusting. We are adjusting the index for the parent node in the tree over here. After doing this one, again, let's perform this one iteration. This will be same. This one here, it has to be less than or equal to n, right? So this is clear. If it is, then again, same thing. If we are just updating, but the process is same, right? Here we have checked for odd and even here. Again, we will be doing the same thing. If it is odd level, then we'll be updating with the OR operation. If it is even level, then we will update with the XOR operation. So for this, I'll just make use of if it is odd, then I'll just write if I module 2 equals 1, then what we will do, this is odd and we will update with the XOR, OR operations, not the XOR operation, OR operation. I can just write this one, tree of I, P. This one will be tree of I minus 1, 2 into P minus 1. Same thing, right? Just this one, OR operation we are performing. So this one will be tree of I minus 1. Again, it will be, we were considering I and J. So we gave this one here and this step, right? You can clearly see we were considering I and J. So we were making use of I minus 1, 2 into J. So here we are considering P and Q, right? So we'll be going with the P and Q. So P, right? Not this one. We are making use of the P. That is nothing but P is the index to update. So here I can just write here 2 into P, right? So this is one thing. Else what we will do? So else if it is even, then we will update with XOR operation. So I'll just copy the same thing, this line, and I'll change the, so sorry, just give me a second here. Let me change from OR to XOR, right? So this is, I hope this is clear. Next step, we have to move to the next parent node. At particular this thing node, we have finished this one and we have updated with the new value. After updating the new value, we have to move to the next parent node, right? So for that, what we will do, we'll just increment this one. I'll just give this one p to p plus 1 by 1 level. So here this is fine. Then next step, finally, we have got the result, but we need to output the result of the current query. Nothing but final value at the top level of the tree, right? So we have got the result here in this step itself, but we have to output the result, right? For outputting, to output the result in the JavaScript, I'll just be making use of to print the result, we'll be making use of console log. Here, tree of n and 1. So we have to go line by line, right? We have to display the output line by line. So I'll just make use of the /n over here. Let's call the function after here. So here, the function name is solve, I think, right? I have made use of solve or mine. Just give me a second here. Yeah, this is solve itself. So this is fine. So yeah, this is it. So let's check whether this works with we'll get the desired output or not. So we have to get the output 1 triple 3. So let me come here. Let me paste this. So we are getting the output 1 triple 3. So you can clearly see here the output that we are getting is 1 triple 3. So the output is correct. So let me paste this one. Just give me a second. So I'll come here. Let me click on submit code. So let's wait for some time. So this is problem D, right? Xenia and bitter operations. I'll just paste the solution over here. Let me hit on submit. So let's wait for some time. I hope this works. And you got a more. So here you can clearly see the solution got accepted, right? So the code works absolutely correct. So yeah, this is it. Thanks for watching, guys.